Okay, 9.5, day 2, we're going to regraph tangent, just to remind you, but then we're going to also graph cotangent, cosecant, and secant. Okay, now I'm going to use the four corners of the circle as a starting point for my graph. This is 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay, tangent is y divided by x. So if I start at 0, 0 divided by 1 is 0, so, which is how I knew that this starts at 0, 0. Okay, I'm going to go to the pi over 2. If I do 1 divided by 0, it is undefined. So there is an asymptote at x equals pi over 2. And then there's also an asymptote at negative pi over 2. Okay, and then to use a extra point, we remembered at pi over 4, x and y are root 2 over 2, root 2 over 2, which means the tangent of pi over 4 is 1. And I got this point down here. And then down here, the tangent of negative pi over 4 was negative 1, and then I got my graph. And I'm going to write that information, and then I'm going to sketch the graph. So my asymptotes were at pi over 2 and negative pi over 2. My nice point was at pi over 4 because the tangent of pi over 4 was 1, and the tangent of negative pi over 4 is negative 1. And then because this goes from negative pi over 2 to pi over 2, the period is pi. Okay, I'm going to go ahead and draw my curve in. I should approach the asymptotes and then go down. Okay, now there's this extra space on the graph. So we're going to continue this graph a little bit farther, and then we're going to consider cotangent. Okay, what happens at pi? Because pi is on my graph. At pi, I have y divided by x. I have 0 divided by 1. That is 0 again. Okay, at 3 pi over 2, I have negative 1 divided by 0, which is undefined, which means there's another asymptote here. Because this is periodic, it's going to keep doing the same pattern over and over again. So this is going to repeat, which means if this is the middle point, it should go up on the right, down on the left, and then it will make another one of these nice little tangent graphs. Okay, and this will repeat forever and ever and ever and ever. Okay, now let's consider cotangent. Okay, now cotangent, let's also start from the unit circle. If I do 0, cotangent is x divided by y. So 1 divided by 0 is undefined. So there's actually an asymptote at 0. Okay, when I get to pi over 2, if I do x divided by y, 0 divided by 1 is 0. So at pi over 2, it's going to be 0. Okay, when I get back to pi, negative 1 divided by 0, undefined. Okay, let's just keep going since we're here. 3 pi over 2, x divided by y. 0 divided by negative 1 is 0. And you can kind of see a pattern going, so I'm going to go ahead and fill in the last one. Okay, I'm going to list unintercept. So at pi over 2, it does hit to 0. It also hits it at 3 pi over 2. It also would at 5 pi over 2 and negative pi over 2. Okay, for my asymptotes, I'm going to list a couple. One is at x equals 0. One is at x equals pi. It's also at 2 pi, 3 pi, 4 pi, 5 pi, and negative 2 pi, 1 pi, all the pi's. Okay, now I need to get a nice point so I can figure out whether this graph is going up, down, what's happening. I'm still going to use pi over 4 because it's so nice. Okay, if I do pi over 4, it's root 2 over 2, root 2 over 2. So if I do cotangent, the x divided by y is still 1. So the pi over 4 is still 1. Pi over 4 is here. Okay, now what are we going to do? Let's do 3 pi over 4. If I go to 3 pi over 4, that's in this quadrant. That's negative root 2 over 2 comma root 2 over 2. If I do x divided by y, I get negative 1. So at 3 pi over 4, it goes to negative 1. And normally you just go the other way, it goes the opposite, which means my graph is going to look like this for cotangent. Okay, once you kind of see the pattern, I can continue the pattern. So at the 0, it goes up on the left and down on the right. And then it repeats and repeats and repeats. Okay, the period of cotangent is pi because from 0 to pi, that's how long it takes to do one of these little waterfalls. So this is one period, this is another period. It keeps going forever and ever and ever and ever and ever, and it goes in the negative direction also. So that's the parent function of cotangent. Okay, now let's look at cosecant and secant. I hopefully showed you the graph on Desmos. Okay, but we can figure this out based on what we know. Okay, cosecant is 1 over sine. So let's pretend like we're graphing sine. Okay, if we're graphing sine, the period is 2 pi. So I'm going to start with that. Okay, now let me think. If we're graphing sine, that's the y value. Okay, the sine of 0 is 0. It normally starts here, but I'm doing the reciprocal. So instead of this graphing 0 here, I'm graphing 1 divided by 0, which is undefined. So there is an asymptote here. Okay, and then normally I go from 0, and then I go up to 1. But I want to do reciprocal. If I do 1 divided by 1, this is going to be 1. Okay, then normally my sine graph goes back to 0. Instead of 0, it's 1 divided by 0, which is undefined. And then my graph goes to -1, but I want to do the reciprocal. If I do 1 divided by -1, I get this. And then when I get back to 2 pi, I'm back to 0, but 1 divided by 0 is undefined. Okay, based on the fact that I showed you what the graph looks like, those are asymptotes, and then it kind of makes like an up parabola shape here. And it makes a down parabola shape here. And we could graph more points, but with those points, we get enough information to get a good graph. So intercepts, where does it hit the x-intercept? Nowhere. There are no intercepts. It also doesn't hit the y-axis anywhere. Okay, my vertical asymptotes, there's one here, there's one here, there's one here, and then there's a bunch more if I were to keep graphing. So there's one at 0, there's one at pi, there's one at 2 pi, there's one at 3 pi, 4 pi, 5 pi, there's a billion. Okay, my nice points are at pi over 2, I went to 1. And at 3 pi over 2, I went to -1. And with that information, I was able to graph the graph. Okay, let's try secant. Okay, now secant is the reciprocal of cosine. So think about how you're going to graph a cosine, and then we're going to flip that point. Okay, when I graph cosine, it normally starts at 1. If I flip 1, I get 1 divided by 1, which is still 1. Okay, after we go to 1, we normally go to 0. Cosine of pi over 2 is 0. If I flip 0, I get 1 divided by 0. 1 divided by 0 is undefined, so there's an asymptote here. So cosine goes 1, 0, -1. If I flip -1, 1 divided by -1 is -1. And then I normally go back to 0, but if I do 1 divided by 0, undefined. And then if I keep going, where am I going to go? 2 pi, I go back to 1, which is going to be up here. Okay, let me look at this pattern. So I go asymptote down, asymptote up, asymptote up. So there's going to be an asymptote on the left here. I'm trying to get at least one period of graph. Okay, does this have an intercept? I mean, it has a y-intercept. The y-intercept is 0, 1. Okay, based on what we kind of know the graph's going to look like, since this is +1, this is going to be an upward direction. Since this is -1, it's going to be in a downward direction. If I kept going, this is going to go up again. It's kind of going to get cut off, but I could draw it in. Okay, my vertical asymptotes, there's an infinite number, but the ones I used were -pi over 2, pi over 2, and 3 pi over 2. And then two important points are going to be 0, 1, and pi -1. Since the period of cosine is 2 pi, the period of secant is also 2 pi. Okay, so those are the parent functions of each of the graph, and these are kind of how we get the points. But we have to know the general shape in order to work faster. Okay, let's try to change some stuff and then see how we do. Okay, 2 secant x. What is secant the reciprocal of? Cosine. Okay, so let me pretend like I'm graphing cosine. Normally if I do cosine, I'll make this pi. I'll make this 2 pi. This has an x, so there's no weird period. There's a little bit of like a vertical stretch, which we'll figure out. Okay, now when I do cosine, what do I normally graph? If I do cosine, normally it starts at 2, goes to 0, down to 0, up here. That's cosine. But I'm doing secant, so I need to flip it. Okay, now if I do the reciprocal of 1, I get 1, and then I times it by 2, I stay at the 2. So this 2 is still valid. It's telling me it's getting vertically stretched. Where the 0 is, there should be an asymptote, because 1 divided by 0 is undefined. Okay, this point is still valid because I do 2 times the reciprocal of -1. But when I get to 0, since I'm doing 1 divided by 0, I get another asymptote. Okay, I want to get 2 periods of this thing. Okay, I already know that I can tell this is going to go down. I want one to go up, so I'm going to go left and then get another up one. Okay, I want to have at least an up and a down to do a full period. If you want to try to squeeze another up over here, you can. It just kind of goes off the graph. Okay, let's do 1/2 the secant of pi x. Okay, since secant is a reciprocal of cosine, I'm going to start it off like I'm going to graph cosine. Okay, and you don't have to graph the points. Oh, what's the amplitude? 1/2? Okay, so this is going to be, if I were doing cosine, it'd be 1/2, 0, negative 1/2, 0, and then back up to 1/2. There is a period change, so I'm going to note the period change. There's a pi x. So normally the period is 2 pi, but I divide it by pi, so the period's 2, which means this should be a 2, and this should be 1. Okay, now I fixed the period. Okay, now this is not cosine, this is secant, so let me make adjustments. So this point is still good, but where the 0 is, that represents an asymptote. This point's good. Where the 0 is, 1 divided by 0 is an asymptote. And then I want one to go up. I'm going to go left and make it go up. Or you could squeeze it on the side. Okay, and then because this is secant, I know it's going to do like an upwards parabola on the positive point and a negative parabola on the negative point. If you want to keep going over here, you could draw another one over here. Okay, but at least do one up and one down. Okay, let's do cosecant of 3x. Cosecant is the reciprocal of sine, so I'm going to set it up like I'm doing sine. I'm not doing the scale because I can see there's a period change. Okay, if I were doing sine, sine goes from 0. What's the amplitude? 1, 0, 1, 0, negative 1, 0. Okay, let me just get that going. Okay, the period is going to be 3x, 2 pi divided by 3, which means this should end at 2 pi divided by 3, which means halfway should be 1 pi divided by 3. Okay, since I'm not doing sine, I'm doing cosecant, I need to flip everything. So where the 0 is, 1 divided by 0 is an asymptote. This point's still good, because when I do the reciprocal of 1, it stays the same. But at this point, asymptote. This point's good. Where the 0 is, asymptote. And then because I know what the graph's going to look like, I'm going to go ahead and sketch my upward and downward u, and include at least one up and down u. If you want to include more, you can include more, but not less. Okay, let's try cotangent. Okay, cotangent. Let me think. I'm going to start here. X divided by y. So we start out at undefined. I think I'm going to space it the same. So what is this? This is pi over 2 and this is pi. Okay, at pi over 2, 0, 1. 0, x divided by y is 0. Ooh, that's going to be too squashed. Let's make this pi over 2. Okay, and then if I go back to pi, negative 1 divided by 0 is going to be another asymptote. Okay, cotangent needs to fit between here and here. So I need to figure out which side's going up and down. Okay, at pi over 4, the cotangent is 1. So at pi over 4 is here. I'm going to go to 1, which means if it's going up on the left, it must go down on the right. Okay, and then once I have those 3 nice points, I'm going to go ahead and sketch my graph. Okay, please include at least a period unless it tells you otherwise, but I think I'm going to do another period just because it fits. Because I know it's going to follow the same pattern. There's going to be an asymptote. There's a 0 in the middle. It went up on the left and down on the right. And once I see the pattern, it's periodic, so it will do it forever and ever and ever. Okay, let's do the cotangent of 2x, which will be very similar, but we're just changing the period. Okay, cotangent of 0 is still going to be an asymptote. Okay, and then normally I go to pi over 2. At pi over 2, it's going to be 0. And then over here, I hit another asymptote. Okay, and then between 0 and pi over 2, I hit that pi over 4, which is positive 1, which tells me it's going to go up on the left and down on the right. Now, I didn't label my scale at all, which is a little bit of a problem. Okay, normally the period for cotangent is pi. Since it's 2x, I'm going to divide by 2, which means one period of tangent should go from pi over 2. So I started with an asymptote at 0. I'm ending with one at pi over 2. So this point over here should be pi over 2. And then my little waterfall shape has fit between 0 and pi over 2. Okay, I'm going to continue one more period of it just because it fits. So there should be another asymptote. I know it hits 0 in the middle, goes up on the left and down on the right. Okay, and if this is pi over 2, this is pi, if you're labeling it. Okay, let's do one more. Tangent, though. Okay, tangent is y divided by x. So 0 divided by 1 is 0. So this is going to start at the 0. Okay, when I get to pi over 2, y divided by x, 1 divided by 0, asymptote. Okay, and then once you see that pattern, you kind of know it's going to keep going. And I can go backwards, forward, it's all going to be the same. So 0, asymptote. Or I can go backwards. It went 0, which means there's an asymptote here. Okay, did my period change at all? No, it didn't change, which means that this is actually pi over 2. Okay, and at least label something on your axis so I know. This is pi over 2, this is pi. Okay, now I just need to figure out if it's going up or down on the right or left. So I'm going to go to pi over 4. At pi over 4, I should get 1. Pi over 4 is between 0 and pi over 2. So here it should be 1. Oh, but there's a shrink. So instead of going all the way up to 1, I'm only going to go halfway up. Okay, because I know what tangent's going to look like, from the 0 it went up on the right, so it's going to go down on the left, but it's only going to go down half because of this shrink. Okay, and then I'm going to draw my nice curvy waterfall shape. Okay, and then it's going to repeat. Since it went up on the right, down on the left, it's going to do that on every single period of this graph forever and ever and ever. I'm including 2 because they fit.